Hi everyone, this is part 2 and in the part 1 we have seen how to check whether there is a path between source and the destination. In that video the source is 0 and the destination was 6, and as soon as we are reaching to the destination we are seeing that yeah we got the path, and in that video we don't care about which path we are following. But let's say if somebody told you how many paths are there and how they look like. So like looking at this example, there is a path 1, 0, 1, 2, 3, 4, 5, 6. So this is path 1. And the path 2 is 0, 1, 2, 3, 4 and 6. The path 3 is 0, 3, 4, 6. If we want to find out all these paths, then how can we write its code? So for that part, I mean, you don't need to write another logic. You just need to change something in this code and you will get your desired answer, right? So in the part 1 video, like we first start with 0, then reach at 1, then 2, then 3, then 4, 5, 6. As soon as we are reaching at the destination, we are returning from that path, and we are make suring that like we are, like in that video what is happening, we are not caring about uh, going its another neighbor of 4, that is 6, and we are returning from that point and we are saying that yeah we got the answer. And also we are not checking for the 3 also. So when we are checking all the possibilities, then only we will get all the possible answer. So I will write the code again by changing some part of it, and will dry run from this example, and you will get to understand each and every line of the code. And there is one more thing that we add in that code. Initially I will not be adding. As soon as we are not getting our answer, we will try to improve our code. Initially I will write the wrong code, I mean there is some minute changes we need to do it further. So the code, like the code will be same. There is something we need to check: graph, source, destination, visited, and if source equal to destination, then we should return from that point. Then we marked visited house. If you are not getting this, then I will recommend you to watch part 1, then you will understand what is going in this part. For auto neighbor of source node, there is some improvement we will do in that code as we dry run it, like where we are going wrong. I will not write the perfect code in the initial, otherwise like you will not get how this code came. So we will do a call again, making neighbor as source node and destination then visited, right? Now we will again do the dry run, right? So this is our example. Okay, make sure that you follow as I am try running this code. This is 0th vertices, 1, 2, 3, 4, 5 and 6, right? Now we will start traversing. So we start with 0 and we need to reach at 6, right? So zeros neighbor are 1 and 3. If you are not getting how am I writing this line, then you should watch the part 1. So zeros neighbor are 1 and 3, and from 1 we wanted to go to 6, 3 also we wanted to go to 6. Now 1, like when we are moving forward from 0 to 1, then we marked 0 as true, right? Now again, from how many neighbors of 1? 0 and 2, right? So we will not, from 0 we wanted to go 6, from 2 also we wanted to go 6. Source is 0 and destination is 6, right? Since 1 is already visited, so we will not go into this path, and then we go to the 2, right? So we came forward from 1 to 2, so we marked 1 as true. Now 2 two neighbors are 1 and 3, right? So see, like we are at 2, we are at this point. Now 2 is not equal to 6, so this will not run. Visited up to, we will mark as true, so this is true. Now we will go its neighbor, so we will be not going to 1 because 1 is already marked as true. We will only be doing the recursive call when neighbors is false, right? So neighbor, this is the neighbor and it is true, so we will not go into this path, we will go into 3. Now we are at this point again. 3 is not equal to 6, so this will not run. Now visited of 3, 3 is false initially, then we will mark as true. So we will, like I will be marking with tick so that we can understand like it is true, right? So 3's neighbors are 0, 2 and 4, right? So 0 is already marked true, so we will not go into this. 2 also. Now 4, yet we are at this point. 4 is not equal to 6, so we will mark 4 as true, right? Now we will check in the neighbor of 4. So 4's neighbors are 3, 5, 6, right? 3 is already marked as true, so we will not go into this. 5 is not marked true, so we will go into this. So we are at this point again. 5 is not equal to 6, we marked 5 as true, right? Now we will check into its neighbor. So neighbors of 5 are 4 and 6, right? Now we will do a recursive call for its neighbor. 5's neighbor is 4, but 4 is already marked true, so we will not go into this path. We only left with 6. Now we are at this point. 6 is equal to 6, so we will return from this point, right? So we got our first answer like this. We got our first answer. Now, so what we do, I mean, we will add something like source, and we are concatenating with the answer we are getting, the node. So we will do a plus in that, like when we are here, so we will do source plus neighbor and in the string form. So we will get our answer like 0, 1, 2, 3, 4, 5 and 6. Now we will be saying that the code is similar to that one, but like as we are doing the remaining part, then you will understand what we need to change in this code. Now we are at 6, so we will return back to this point. Now we are at 5, and at this, in 5 we are at this point, and we are done with all the neighbors of the 5, so we will return true from this path. And then we came at 4. Now we are at 4, and we in 4 we are at this point. So 2, like 4 has 3 neighbors and 2 are already done. Now we are at 6, right? 6. So in the first part, like you have seen that we are at 4 and we are at this point inside this, and uh no, I think there is one more thing. I think, yeah, sorry. See, in this part you see we are at 4, right? We are at 4, and we are not going in this 6 because of this line, because we are getting true, like this part is returning true, the answer is storing the part as true, so that's why we are returning from this point. But in this code we are not writing this part. Why? Because we don't want it to we all wanted the all possibilities, so we will not be returning from this point until we are checking all the neighbors. So that's why we are removing this line in this code. So that's why we have the opportunity to traverse this path also, right? And see, we are not passing this in this point as the what I said, there are two ways to pass the argument, as pass by reference and pass by value. So we will pass it by value, so that like whenever we are moving forward, then these things will remove from this. So we are at this point, and from this we will check the remaining neighbor, that is 6. So we came to this 6. Now we are at this point. Source is equal to destination, so again we will say return. So the second path will be like 0 1 2 3 4 and then 6. Again, see, now we are done with this, done with 4. Now we came to this 3, return back to this 3 because of this, and then we are done with all the neighbors of 3. Then again we return back to 2. So 2's all the neighbors are done, so we will return back from 2 to 1. Then once all the neighbors are done, now we will return back to 0. Now we are at 0 and we are done with this and this thing. Sorry, we are at this point in 0. We are done with its first neighbor. We are done with 0's first neighbor. Now we wanted to go to 3. We wanted to check to the 3, but see, 3 is already marked true. If 3 is not false, then our recursive call will not run. So that's why I told you that there is something that we need to change in this code. And so changing this, so when we are returning, we need to mark visited of that source as false. So we need to add one more thing, visited of src as false. Then only we will be able to traverse all the things, right? So let's say again we start try running the code, so that you will understand how this is impacting our code. So we started with 0, we marked 0 as true, we came to 1, then we will not go into 0, we will go to 2, we mark 2 as true, then we check its neighbor, then we will not be going to 1 because it's already marked true. Then we came to 3, then 3 we check all the neighbors of 3, then we marked 3's neighbor as true. Then we came to 4, then we marked 4 as true. Then we came to 5, then we marked 5 as true. Then we came to 6, right? When we are at 6, so we are not marking 6 as true, or because we are not going further. Let's say we are at 6, so from this point we are returning, we are not coming to this point, so that's why 6 is not marked as true. Now we return back to 5. Now we are done with all the neighbors of 5. Now see, we are in this, like when I say 5, I mean we are standing at this point. We are done with this point because this is not true, we already marked this. Now we are at this point, right? Now see, we are done with this and we wanted to move backward from 5 to 4, but we, like whenever we are done with the neighbors of 5 and before returning back from 5, we mark 5 as false again. So we will say marked 5 as false again. Now we return back to 4. See, as soon as I am done with all the neighbors of 4, then again, like I am at 4, so as soon as I am done with all the neighbors of 4, I will mark 4 as false. So I will mark 4 as false. Now again I am done with all the neighbors of 3, then I will mark 3 as false. Again I am done with all the neighbors of 2, so I will mark 2 as false. Now I am done with the neighbors of 1, so I will mark 1 as false. Now I am at 0, I am done with first neighbor of 0. Now I wanted to go to 3, and if I will be only able to go to 3 if 3 is marked as false. So right, whenever, so I already marked 3 as false, so that's why I am able to go into 3. So let's say I am at 0, I am done with its first neighbor. Now it's time to go its second neighbor, that is 3, and 3 is marked as false, so we will do a recursive call in 3. So 3's neighbors are 0, 2, then 4, right? So 4 is already marked as true, so we will not go into this. Now 2 again we have to do the same thing, right? And we know that from 2 we will not able to find the path because we will be able to go to this, and we can't go this path because this is already marked as true, right? So the thing is that we will not do a dry run for this part, we will do a dry run for this part because we know that we will be getting answer from this path. So we are at 4. Now 4 is not equal to 6, so we mark 4 again as true, and then we already marked again 3 as true, right? Now we are at 4, so 4's neighbors are again 5 and 6. We already marked 5 as true, sorry, false, so we have the possibility to go into 5 remaining things, and but we know, and from that point also we will be getting a path. So from there also we are getting the path, but like we will check with this 6. Now we are at 6, right? We marked this as, we already marked true. Now we are at 6, right? 6 is equal to 6, so we will return from this point. So again we got another path, that is 0, 3, 4 and 6. So this is how improving this code will lead you to all the possibilities to reach from source to destination. So I hope you will get this point. And I will suggest you to dry run the part 1 and the part 2, so that you will understand how much improvement you wanted to do in the code. And if you are able to dry run with this in the same format, then you will get the understanding, because mostly graph is all about dry running the input and getting to the final result as per the code, not with your own thoughts, right? So that's all for the video. Thank you.